Welcome to the technical demonstration of EGI's recommended workflow for source estimation using GeoSource 3.0 Research Advanced. Please note that this is a guideline for the workflow. Each time you start with a new file, your steps may change based on the data in your file. This workflow requires you to already have an individual head model generated. If you have questions, please contact support. Open a file in NetStation Review that has been prepared for source localization. The data needs to be clean of all artifacts, including DC offset, and have a good signal-to-noise ratio. Choose the default keyboard set. This has the controls set up for best use with GeoSource 3.0 research. Assess data to form a hypothesis for results in the source estimation. Open a workspace created for EEG source estimation. This workspace has a chart, plot, butterfly, and map view. Click the P key on the keyboard for snap to peak so that the timesync marker is placed on the maximum voltage. Lock the color palette range for the topo map to the peak. Look at plot and map to get an idea of the location and orientation of the source or sources that may be contributing to the scalp topography. The dipolar activation has a positive and negative field projection on the scalp. The source would be located in the neutral gradient somewhere in between. Click on Chart View to make it active. The reciprocity visualization environment will pull the EEG data from this default chart view to make the calculations. It will send the following information: data for all sensors in your file, not only the ones being viewed in the chart view montage. Sensors marked bad will not be used to compute the scalp interpolation or source calculations. Viewer filters, and mean correction setting. Click the View button in the bottom tray to bring back your viewing options. Click on the Reciprocity Viewer icon in your Views menu. Select the options for the imaging specification. Choose your constraint for the inverse algorithm. S-Loretta is most constrained, so we reserve that algorithm for use with the most constrained head model, which would be an individual head model. We're going to be using an individual head model, so I'm going to choose S-Loretta. Choose your regularization level. Start with values near the provided default. I'm going to keep the selection to -3. This scale uses scientific notation so that 10 to the -1 is more regularization than 10 to the -3. Regularization adds additional smoothing constraints on your results so that you can reduce variance in your data and help the signal-to-noise ratio. Choose your forward model calculation method, finite difference method or realistic model, or spherical Sun-Stoke 4-shell model. Choose your head model. There is an individual example head model that is provided as a demonstration of how the RVE would visualize an individual head model. It is not recommended to use this model for analysis. The EEG and the individual head model have to be from the same person in order to interpret source results. In the drop-down, select Import New Head Model. Browse through your computer to find the GSRC file that you created from the electric head model generation. Click Select File to import by copying. If you do not want to copy the file to your local folders, you can change this in your NetStation preferences. Now select the head model from the list. Click Launch. The reciprocity visualization environment will load in a separate window. You can see the icon for the RVE down in the dock. Once it is loaded, you can organize your screen to better fit all your windows. We don't recommend updating your workspace once you have the RVE open, as NetStation will then try to launch the RVE every time you access the workspace, which will not allow you time to provide user input before it launches. The head model is listed at the top of the window along with the file name. The left column has all the function controls for the view you have in the center. To change your view to another option, you can use the column on the right. We recommend starting with the Scalp Topography Exploration. Click on Scalp Topography Exploration. Use the 3D topo map to assess your data and further your understanding of the data in the 3D space. Hold down the left-click button and drag to view different sides of the 3D topo map. Click on View in the toolbar to use default controls to change the viewing angle. You can zoom in and out by holding down the right-click button and dragging the mouse. You can move the images on the screen by holding the Shift key and then the right-click button and dragging the mouse to move the image. Move through the EEG using the left and right arrow keys to nudge through the event. This will allow you to see how the topo map changes over time. Review the head model that was created in the MIP for accuracy in segmentation and sensor registration. This is helpful, especially if you did not create the head model yourself. Click on the GPS image to review the sensor registration accuracy for this head model. Use the same controls as in the Scalp Topography view to move the image around. Click on Tissue Segmentation to review the anatomy of the head model. Rearrange the views to make the MR images larger. Change the opacity of the MR image volume in the view controls on the left. With the individual model, you will want to make sure the segmentation has been done correctly to identify the 7 different tissue types. Click and drag in the 2D MRI images to move through the slices. You can also use the up and down arrow keys once you've clicked on a slice. To change the brightness, you can hold Command, right-click, and then drag left and right. To change contrast, you can hold Command, right-click, and then drag up and down. Click on Individual-Oriented Sources to view the source results. Now you see the 2 source scenes in the middle window. Both scenes have the scalp mesh displaying the EEG topography. Both scenes are also displaying the same head model in 2 different ways. The model on the left has the surface mesh of the cerebral cortex. The model on the right has an inflated surface mesh of the cerebral cortex. This view is helpful to see the deeper areas in the sulci of the brain model. Along the bottom, we can see the 2D MRI slices that were used to build this head model. Click back to review and set the time sync marker to the peak of the event in the EEG. Now we're going to set the palette so that the maximum voltage in the data is locked to the maximum color intensity in the result. This bright yellow on the positive end or white on the negative end. So now my data set will be represented with a color palette relative to that maximum, and we can evaluate the source results with a color palette that will be consistent across time points. The EEG data used to calculate these results is coming from the default chart view in Review. You can see any viewer filters that are being applied to this data by looking here underneath the color palette. Assess results. Values in source estimation represent the relative strength of a dipole required to reconstruct the scalp topography in question. The different dipoles can be visually identified by patches of color. The individual head model describes the subject's own cortical surface, which means each dipole has a fixed orientation in relation to the cortical surface. For every given dipole, the source results give you a single value that represents 2 things: the current being generated at that position and its contribution to the potential field measured on the scalp. The white to blue, or negative range of the palette, indicates that the dipole is contributing a negative potential field to the scalp topography. The negative end of the dipole is pointing outward. The yellow to red, or positive range of the palette, indicates that the dipole is contributing a positive potential field to the scalp topography. This positive end of the dipole is pointing outward. The absolute value of the source results reflects the intensity of the current being generated at that dipole patch. Use the same controls as in the topography view to view the results from different angles. Use the view controls in the top left to change the opacity of the scalp mesh or the size of the electrodes. When you hover the mouse over a dipole, you can see the value of the source result. When you click on a dipole patch, you will see the arrow to visualize the orientation of that dipole to the cortical surface. You can change the source threshold to focus on dipoles with higher absolute intensity results. Click back to review and change your timescale in the chart to 1:1. Evaluate temporal stability. Move the time sync marker earlier in time before the event to look at how this event starts. Navigate through time using the left and right arrow keyboard shortcuts to move along sample by sample. How stable is the source over time? You can evaluate the relationship between the sources that end up on the high end of either side of the palette, maximum negative or maximum positive, by assessing how they develop over time. For example, does the negativity show before the positivity? Are they always linked in time? You can also use their orientation to each other to evaluate if they may be from the same source or linked in a cortical network. Click back to review and view a different category of EEG to look at another category of EEG in the RVE. Notice that the category name in the EEG category reflects the new category you chose in review. From review, you can also load another imaging specification into the RVE. Click back to the original category. Click on the Reciprocity Viewer icon again and choose your second imaging specification. You can choose up to 4 imaging specifications for each head model you've loaded. You can load up to 2 head models in the RVE for a total of 8 imaging specifications loaded at once. Choose a different head model. You could import a new head model, but I'm going to choose the 32-year-old male for my second head model. The Atlas models will visualize the source results in a different way than the individual model. In the individual model, the orientation of the dipole is already described, regardless of what EEG data we put into the model. Therefore, we can use one color palette to show 2 things: the intensity of the current and the polarity of the potential field of the dipole that is projecting outward. Make sure to lock the palette. In an Atlas model, the information cannot be displayed in the same way because the orientation of the dipole to the cortical surface is unknown. The vector is going to tell us the orientation of the dipole at that voxel and the direction of the corresponding potential fields generated at that voxel. The color palette of the source results is only used to describe the intensity of current at that location. Compare the results with this model to the previous model. Switch back to the other head model. Click on File, Switch Head Model, and select the individual head model. Return to review and launch the RVE one more time and add another imaging specification to the model. Choose LoRa -3 FDM. Lock the palette and compare the results. Notice the values that represent the range to which the palette is locked. Switch back to S-Loretta -3 FDM under Imaging Spec by clicking the drop-down next to Method. It will only allow you to change to other imaging specs you have loaded through review. To close a spec, load the spec in the RVE and click Close Current Spec. Make sure you lock the palette again. You will need to lock the palette every time you switch to a new imaging specification. It will stay locked to a specific range of values across different imaging specs, even if you switch to a new one. For example, it is locked to the results for LoRa -3 FDM. Reset it to the current imaging spec ranges by unchecking the box, moving the timesync marker to the peak, or nudging back and forth so you know RVE is updated, and then checking the box again. Create a collection of different dipole groups by adding a source collection. You can use the source threshold to help decide which dipoles you would like to select. Under Oriented Collections, click on All Sources. Select New Oriented Collection. Enter a collection name. When you choose the name for the source collection, you can, for example, give it the name of a patient or condition within your study. Then the dipole source groups can have more specific names, like right motor cortex or left anterior temporal. Select the dipoles to create a dipole source group. You can click on a dipole to select it. To select multiple dipoles, you can hold the Command key and then click on each dipole you want to add to the selection. In the Source Collection menu on the left, click the Add Selection button, and then choose to add these dipoles to a new or existing dipole group. Choose New Group. Enter a source group name. Select the color with which this new selection of dipoles will be highlighted. Clicking the checkbox next to the dipole group will show or hide the dipole group in the volume view. You can edit and delete groups using the buttons in the menu. You can now view the scalp voltage of the group projection only versus the entire EEG at that point in time. In the left column under GeoSource and Topographies, click on Group Projection under the Sensor Voltage field and under Scalp Voltage field. Notice the menu at the top now says Lead Field Projection to reflect the data you're seeing on the scalp mesh. This is the projection of the dipole group you have selected in the Oriented Collections. Click on EEG category to see the projection of all of the dipoles in your model from the EEG category you are viewing. You can also view projections of individual dipoles by clicking the Group Projections buttons and unchecking the dipole group on the left. Now click around the model to see projections of individual dipoles. If you would like to evaluate the forward projection for a dipole or group of dipoles, then you can look at the individual electrophysics review. This view will show the forward projection of each dipole and does not take into account any source results for this projection. You can view the forward projection of dipole groups from any source collection, or select other dipoles or groups of dipoles using the same controls from the other view. Thank you for watching the technical demonstration of the recommended workflow for GeoSource 3.0 Research Advanced. For further information, please contact EGI support.